Have you ever gazed at the moon and wondered about the secrets it holds? From its role in shaping life on Earth to its stunning features visible even from millions of miles away, the moon is more than just a celestial companion. It's a world of wonder, with mysteries waiting to be unraveled. Are you ready to dive into 10 incredible things about the moon? Join us as we explore its fascinating facts, ancient impacts, and surprising characteristics. The moon was formed by a massive collision. One of the most fascinating aspects of the moon's origin is its dramatic creation story. Scientists believe the moon was formed around 4.5 billion years ago when a Mars-sized object named Theia collided with Earth. This cataclysmic event ejected a massive amount of debris into space, which eventually coalesced to form the moon. Evidence of this giant impact hypothesis lies in the moon's composition. Lunar rocks collected during the Apollo missions show a remarkable similarity to Earth's mantle, suggesting that both celestial bodies share a common origin. This finding has helped scientists piece together the violent history of our early solar system. The moon's formation played a pivotal role in Earth's evolution. The massive collision tilted Earth's axis, creating the seasons we experience today. Additionally, the moon's gravitational pull helped stabilize Earth's rotation, preventing chaotic wobbling that could have drastically altered our planet's climate. While we now have a clear idea of how the moon came to be, there are still ongoing studies aimed at understanding the finer details of its formation. Space missions and advanced simulations continue to shed light on the early years of Earth and the moon's shared history. The moon's birth story isn't just about its formation. It's a testament to the dynamic and often violent processes that shape the cosmos. Understanding this dramatic event helps us appreciate the interconnectedness of celestial bodies within our solar system. The moon influences life on Earth. The moon is more than a distant companion. It plays a critical role in shaping life on Earth. Its gravitational pull is the primary force behind ocean tides, creating the rhythmic rise and fall of water levels that have been vital to coastal ecosystems for billions of years. These tides, influenced by the moon's phases, help regulate marine life cycles. From coral spawning to the behavior of fish and other sea creatures, the moon's pull sets the pace for life in the ocean. Without the moon's steady influence, these ecosystems might not have developed as they have. The moon also impacts Earth's rotation. As the moon's gravity interacts with our planet, it slows Earth's spin by about 1.5 milliseconds per century. While this seems insignificant, it has a profound cumulative effect. Millions of years ago, a day on Earth was only about 18 hours long, but thanks to the moon, we now enjoy 24-hour days. The moon's presence in the night sky has also influenced human culture, from mythology and literature to calendars and rituals. Ancient civilizations carefully observed their phases to track time, plan agricultural activities, and guide navigation. The moon's impact on life extends far beyond tides. It's a silent but ever-present force that shapes our environment, culture, and daily rhythms. Without it, Earth as we know it would be an entirely different world. The moon has a far side, not a dark side. The far side of the moon has often been misnamed the dark side. But this is a common misconception. Both sides of the moon experience day and night cycles, just like Earth. The far side is simply the part of the moon that faces away from Earth due to tidal locking. Tidal locking means the moon rotates on its axis at the same rate that it orbits Earth, causing one side to always face us. This phenomenon is why we only see the familiar features of the near side, like the Sea of Tranquility and the Tycho crater, while the far side remains hidden from view. The far side of the moon was first glimpsed by humans in 1959, thanks to the Soviet Luna 3 spacecraft. This side has a rugged, heavily cratered surface, starkly different from the near side's smoother, darker plains. The lack of maria or lunar seas on the far side is attributed to differences in crust thickness and volcanic activity during the moon's early history. It continues to provide valuable insights. In 2019, China's Chang'e 4 mission became the first spacecraft to land on the far side, uncovering data about its unique geology and deep craters that could hold clues to the solar system's formation. The mystery of the moon's far side captures the human imagination, reminding us of the unseen wonders that await exploration in our cosmic backyard. The moon is shrinking. The moon is slowly shrinking as its interior cools. This cooling process causes the moon's crust to contract, resulting in the formation of cliffs called lunar scarps. These scarps can rise as high as 300 feet and stretch for miles across the lunar surface. NASA's Lunar Reconnaissance Orbiter has captured images of these scarps, revealing that they are relatively young in geological terms, just a few 100 million years old. Some scarps even show evidence of ongoing activity, indicating that the moon is still geologically dynamic. This contraction has caused occasional moonquakes. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes occur due to the moon's shrinking crust and the gravitational pull of Earth. While they are not as intense as earthquakes, moonquakes can last much longer, sometimes up to 10 minutes. The shrinking moon also provides clues about its thermal evolution. Scientists study the size and distribution of scarps to understand how the moon's interior has cooled over billions of years, offering insights into the thermal histories of other rocky worlds. The shrinking process is a reminder that even celestial bodies we consider static and unchanging are constantly evolving. The moon continues to surprise us with its ongoing activity and the secrets it holds beneath its surface. Moon dust is surprisingly dangerous. The lunar surface is covered in a fine layer of dust known as regolith. While it may look harmless, this dust is surprisingly dangerous. Lunar regolith is composed of tiny, sharp particles created by billions of years of meteoroid impacts, which have pulverized the moon's surface. During the Apollo missions, astronauts discovered firsthand how problematic moon dust could be. It clung to their suits and equipment, and even got into the lunar module, causing respiratory irritation and damaging seals on spacesuits and machinery. The jagged edges of lunar dust particles make them abrasive, posing a significant challenge for future lunar missions. Prolonged exposure to these particles could harm both humans and equipment, necessitating innovative solutions for dust mitigation. Despite its dangers, lunar regolith has potential scientific and practical applications. It could be used as a building material for future lunar habitats or as a source of oxygen through chemical processing. Researchers are exploring ways to harness this abundant resource while mitigating its risks. Moon dust serves as a reminder of the challenges and opportunities that await humanity as we prepare to return to the moon. The moon is slowly drifting away from Earth. The moon isn't as stationary as it might seem. It's actually moving farther away from Earth at a rate of about 1.5 inches per year. This slow drift is caused by the gravitational interactions between Earth and the moon, specifically the transfer of angular momentum due to ocean tides. Tidal forces create a slight bulge in Earth's oceans, which exerts a gravitational pull on the moon. This pull adds energy to the moon's orbit, causing it to spiral outward over time. Though the change is gradual, it has profound implications for Earth and its future. As the moon drifts away, its impact on Earth's tides diminishes. Over billions of years, this could lead to less dramatic tidal changes, which might significantly alter coastal ecosystems that rely on the moon's gravitational pull. Additionally, the moon's distance affects solar eclipses. A more distant moon will appear smaller in the sky, eventually making total solar eclipses a thing of the past. This phenomenon also tells scientists about the Earth-Moon system's history. By studying lunar rocks and Earth's geological layers, researchers have pieced together how the moon's gradual drift has influenced Earth's rotation and climate over millions of years. The moon's drift reminds us that even the most familiar celestial bodies are not static. They are part of a dynamic and ever-changing universe with ripple effects that extend across space and time. The moon has an atmosphere, but it's extremely thin. Contrary to popular belief, the moon does have an atmosphere, but it's so thin and fragile that it's called an exosphere. This exosphere is composed of rarefied gases, including helium, neon, and argon, which are present in trace amounts compared to Earth's dense atmosphere. The moon's exosphere is constantly being replenished by several processes. Solar wind particles, micrometeoroid impacts, and the slow release of gases from the lunar surface all contribute to this tenuous layer. Unlike Earth's atmosphere, the exosphere doesn't provide protection from radiation or support for breathable air. Because of its lack of a substantial atmosphere, the moon experiences extreme temperature swings. Daytime temperatures can soar to 260 degrees Fahrenheit, while nighttime temperatures plummet to -280 degrees Fahrenheit. Without an atmospheric buffer, there's nothing to distribute heat evenly or shield the surface from direct solar radiation. This thin exosphere still holds valuable scientific insights. For instance, studying the moon's exosphere can help scientists understand the behavior of gases on other airless celestial bodies, such as Mercury and certain moons of Jupiter and Saturn. The moon's delicate exosphere highlights the challenges of future human exploration and settlement, as well as the ingenuity required to adapt to its harsh environment. The moon experiences moonquakes. Just like Earth experiences earthquakes, the moon has its own seismic activity, known as moonquakes. These quakes were first detected during the Apollo missions when astronauts left seismometers on the lunar surface. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes have different origins. Moonquakes can be triggered by the gravitational pull of Earth, meteorite impacts, thermal expansion from sunlight, or the moon's internal cooling and contraction. Some of these quakes can last for an extended period up to 10 minutes because the moon lacks the water-rich rocks found on Earth that help dampen seismic vibrations. There are 4 types of moonquakes: deep, shallow, thermal, and those caused by meteor impacts. Shallow moonquakes in particular can be quite powerful, reaching magnitudes of up to 5.5 on the Richter scale, enough to cause structural damage if humans were living on the moon. Understanding moonquakes is essential for designing safe habitats for future lunar missions. Structures must be resilient enough to withstand these quakes and other environmental hazards. Moonquakes reveal that the moon is not as geologically dead as we once believed. It's a reminder that even a seemingly barren world can have dynamic internal processes that are crucial for scientists to study. The moon has water, but it's trapped in ice. The discovery of water on the moon has been one of the most groundbreaking revelations of the 21st century. In 2009, NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, mission confirmed the presence of water ice in permanently shadowed craters at the moon's poles. These craters, located in regions that never receive sunlight, act as cold traps where temperatures can drop below -400 degrees Fahrenheit. At these frigid conditions, water molecules become frozen and remain preserved for potentially billions of years. This water ice holds immense significance for future lunar exploration. It could be used as a resource for drinking water, oxygen production, and even rocket fuel through the process of electrolysis. The ability to harness lunar water would make long-term habitation and deep space exploration more feasible. Scientists are also studying the origin of this water. It could have been delivered by comets and asteroids, or formed through chemical reactions between solar wind particles and the moon's surface. Understanding its origin provides insights into the history of water in our solar system. The moon's icy reserves symbolize untapped potential for human exploration and survival, paving the way for a new era of space travel and scientific discovery. The moon might hold clues about Earth's early history. The moon is often referred to as a time capsule for Earth's early history. Because it lacks weather, tectonic activity, and a thick atmosphere, its surface has preserved ancient features and records that have been erased from Earth over billions of years. Lunar rocks and soil provide clues about the early solar system. By studying the moon's composition, scientists have learned about the bombardment of asteroids and comets that occurred during a period known as the Late Heavy Bombardment. This era shaped not only the moon but also Earth, potentially delivering water and organic compounds critical for life. The moon's surface also offers a record of solar activity. By examining isotopes in lunar rocks, researchers can reconstruct the history of the sun's radiation and its effects on the inner solar system. Additionally, the moon's relatively unchanged crust holds information about Earth's early crust and mantle. Comparing the two bodies helps scientists understand how the Earth-Moon system has evolved over time, including the dynamics of Earth's magnetic field and plate tectonics. The moon's preserved history acts as a window into our past, reminding us that studying our closest neighbor can uncover secrets about the origins of our planet and the conditions that made life possible. The moon is a celestial treasure trove of mysteries and wonders, each fact revealing a deeper connection between our planet and its natural satellite. From its drifting orbit to the water hidden within its craters, the moon is far more complex and fascinating than it first appears. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the universe's wonders with us. Have you ever thought about the discoveries that have reshaped our world as we know it? From breakthroughs that redefined medicine to insights that opened new windows to our universe, the 20th century was packed with game-changing scientific revelations. Curious about the discoveries that brought us into the modern age? Join us as we explore 8 remarkable scientific discoveries of the 20th century that changed everything, from our health and technology to our understanding of life itself. Penicillin, the accidental miracle. All right, picture this, it's the 1920s and even a tiny cut or scrape could lead to a life-threatening infection. That was reality before one incredible accident changed everything. In 1928, Scottish scientist Alexander Fleming was studying bacteria in his lab when he noticed something strange. A mold, just ordinary mold, had accidentally landed in one of his petri dishes. But here's the catch. The bacteria near the mold were completely wiped out. That mold was producing something powerful, which Fleming would soon call penicillin. This wasn't an instant breakthrough, though. Transforming penicillin into a usable drug took years of research and experimentation. But by World War II, it was saving lives on the battlefield, treating infected wounds that would have otherwise been deadly. Suddenly, medicine had an answer for infections, turning what used to be death sentences into easily treatable conditions. Imagine the relief of doctors and patients alike. This was a whole new world. The impact of penicillin went way beyond its immediate use. It opened the door to discovering other antibiotics, each developed to target different types of bacteria. Today, it remains a critical tool, though we've had to adapt, especially as bacteria become resistant over time. But still, Fleming's accidental miracle is a reminder that some of the biggest advances come from unexpected places. Who knew a bit of mold could lead to one of the most transformative discoveries in all of medicine? DNA, the code of life unveiled. Imagine cracking the code to what makes you, you. Back in the early 1950s, scientists were on a mission to understand the very blueprint of life itself. In 1953, 2 researchers, James Watson and Francis Crick, took a huge leap by discovering the double helix structure of DNA. This twisted ladder shape wasn't just a neat pattern, it was the key to understanding how genetic information is stored and passed down from generation to generation. Every little detail, from eye color to genetic disorders, is written in this microscopic code. But here's where it gets even cooler. DNA doesn't just store information, it can actually replicate itself. That's right. Each strand carries the power to make a copy of itself, which is why life can grow, repair, and adapt. With this discovery, science began to decode the very language of biology. And it didn't stop there. Understanding DNA opened up endless possibilities for medicine, agriculture, and even forensic science. Think about genetic testing, for example. Now we can identify risks for certain diseases, match organ donors, and even solve cold cases. DNA's role in everyday life has become monumental, and we're still finding new ways to use this knowledge. Thanks to this breakthrough, we're able to manipulate DNA to fight genetic disorders and develop personalized medicine that fits our unique genetic makeup. Watson and Crick's discovery was more than just a scientific win. It was a game changer that forever altered our understanding of life. We've only scratched the surface of what DNA can teach us, but one thing's clear, it's the ultimate blueprint of life. Quantum mechanics, unlocking the microscopic world. All right, let's dive into a world that's as strange as it is mind-blowing. The world of quantum mechanics. Imagine trying to understand how particles work on a microscopic level. Tiny particles like electrons and photons. In the early 20th century, scientists like Max Planck, Niels Bohr, and Albert Einstein started realizing that the rules of physics we know don't quite apply when you zoom in close. Instead, particles behave in ways that seem to defy logic. Take this. In the quantum world, particles can exist in multiple states at once, a phenomenon called superposition. It's like flipping a coin and having it be both heads and tails until you look at it. And then there's entanglement, where particles separated by huge distances can instantly affect each other. Einstein himself called this spooky action at a distance because it was so mind-bendingly weird. Quantum mechanics didn't just change our understanding of particles, it revolutionized technology. Without it, we wouldn't have things like lasers, MRI machines, or the foundations of modern computing. Quantum principles power the tech behind semiconductors, making computers and smartphones possible. Imagine that our entire digital world stems from understanding the weird behavior of tiny particles. This field is still growing, especially with quantum computing on the horizon. Scientists are working to harness the power of superposition and entanglement to create computers far more powerful than anything we have today. Quantum mechanics might sound like a science fiction plot, but it's very real. And it's set to transform our future in ways we're only beginning to understand. Relativity, redefining time and space. Picture this, the fabric of time and space bending and stretching, almost like a cosmic rubber sheet. That's the idea behind Einstein's theory of relativity, which completely transformed how we see the universe. Back in the early 20th century, Einstein proposed that gravity isn't just a force pulling objects together. Instead, massive objects like planets and stars warp the space around them, creating what we perceive as gravity. It's mind-blowing. Now, relativity has two parts. First, there's special relativity, which tells us that the faster you move, the slower time passes for you. Yep, time actually slows down. If you were speeding near the speed of light, you'd age more slowly than someone standing still. Then we have general relativity, which expands this concept to include gravity. According to this theory, gravity can even bend light. So when you see distant stars twinkling, their light might be bending around massive objects along the way. This idea completely redefined how we understand space and time. They're not separate things, but interconnected in a fabric called space-time. This concept laid the foundation for modern astrophysics, helping us understand black holes, the Big Bang, and even the expansion of the universe. And here's something wild. GPS satellites need to account for relativity. Time moves slightly faster in space, so without adjustments, our GPS systems would go haywire. Relativity isn't just theory. It's essential to our tech and helps explain the vast, mysterious universe around us. Einstein's work reshaped science and will likely keep guiding us toward cosmic discoveries for decades to come. The Big Bang Theory, a glimpse into the universe's origins. Imagine the entire universe condensed into a single tiny point, a point so dense and so hot that it defies comprehension. That's where the Big Bang Theory comes in, giving us a glimpse into the origins of everything around us. According to this theory, about 13.8 billion years ago, that tiny point suddenly expanded, setting off a massive explosion that would eventually lead to galaxies, stars, planets, and, well, us. It wasn't a bang as in sound, but more like an intense, rapid expansion that set everything into motion. What's even wilder, the universe is still expanding. Scientists figured this out when they observed that galaxies are moving away from us, and the farther they are, the faster they're receding. It's like dots on a balloon being blown up. They all move away from each other as the balloon gets bigger. This discovery was one of the biggest game changers in astrophysics, leading us to the understanding that the universe has a dynamic past and isn't just a static, eternal space. The Big Bang Theory also gave rise to cosmic microwave background radiation, basically leftover heat from the universe's early days. By studying this ancient glow, scientists have gathered clues about the universe's infancy, and even the conditions that led to the formation of matter itself. So when you look up at the night sky, you're seeing galaxies that all started from a single point, connected by an ancient history that we're still uncovering. The Big Bang Theory doesn't just tell us where we came from, it opens up mind-bending possibilities about where we're headed as we journey deeper into the cosmos. Antibiotics beyond penicillin, expanding the arsenal against infection. Let's talk about the unsung heroes that took penicillin's place in the fight against infections. After the discovery of penicillin, scientists realized that this wasn't just a one-time miracle, it was the beginning of an entire field of antibiotic research. Penicillin was incredible, but it couldn't tackle every type of bacteria out there. So researchers began developing new antibiotics, each one designed to target specific infections that penicillin couldn't touch. Take streptomycin, for example. This antibiotic became a game-changer in the fight against tuberculosis, an infection that ravaged populations worldwide. Streptomycin showed us that antibiotics could be specialized tools, custom-built to attack different kinds of bacterial infections. Then came tetracycline, which opened up even more possibilities, treating a range of infections from acne to respiratory illnesses and becoming a staple in medicine cabinets around the world. And it didn't stop there. With antibiotics like vancomycin and ciprofloxacin, scientists kept pushing the boundaries, creating stronger, more targeted treatments as bacteria evolved and developed resistance. It's like an arms race where bacteria adapt and scientists respond with new weapons, staying one step ahead in this ongoing battle. These antibiotics, beyond just penicillin, expanded the medical arsenal and saved countless lives. They're the backbone of modern medicine, making everything from surgeries to routine infections far less dangerous. Without this growing family of antibiotics, healthcare as we know it would look a lot different. So here's to the power of scientific innovation in keeping us healthy and pushing forward in the battle against infection. Plate tectonics, explaining Earth's dynamic surface. Imagine Earth's surface as a giant puzzle, where each piece is constantly shifting. That's the idea behind plate tectonics, a revolutionary concept that changed how we see our planet. Before this theory, no one could explain why earthquakes happened or how mountains formed. But with plate tectonics, scientists realized the Earth's crust is divided into huge, rigid plates that float on molten rock beneath them, moving and interacting in mind-blowing ways. Now, these plates don't just sit still. They're in constant motion, driven by heat from Earth's core. Some plates pull apart, creating vast ocean ridges where new crust is formed, like the Atlantic Ocean getting wider every year. Others collide, forcing one plate beneath the other and forming mountains like the Himalayas. And when plates slide past each other, that's when earthquakes strike, releasing massive amounts of energy that can reshape entire landscapes in seconds. This theory explains everything from the creation of continents to volcanic eruptions. Before plate tectonics, we didn't really understand that Earth's surface is alive and evolving. It's like a giant conveyor belt, recycling crust back into the mantle in some places and forming new land in others. This concept turned geology on its head and gave us a deeper understanding of Earth's history and future. Plate tectonics isn't just about understanding natural disasters. It's a key to exploring Earth's geological past, from the shifting of ancient supercontinents to predicting future land formations. It's a dynamic vision of our planet, and it changed the way we understand the very ground beneath our feet. Insulin, a lifesaver for millions. Imagine being told that a diagnosis is essentially a life sentence. This was the reality for people with diabetes before the discovery of insulin. Back in the early 20th century, diabetes was a devastating condition with no real solution. But then came a breakthrough that would forever change lives. Insulin. Discovered by Dr. Frederick Banting and Charles Best in 1921, insulin became the lifeline that millions of people desperately needed. So how does insulin actually work? In simple terms, it's like the key that lets sugar move from your bloodstream into your cells, where it can be used for energy. Without insulin, blood sugar builds up and the body can't function properly. By figuring out how to extract and administer insulin, Banting and his team unlocked a way to manage diabetes, essentially giving people back their lives. The impact was immediate and profound. Before insulin, diabetes was often fatal. After insulin, patients who once faced inevitable decline were able to live full lives. Imagine the relief and hope it brought to families around the world. It was nothing short of miraculous. And what's even more amazing? Over the years, scientists have developed new forms of insulin and delivery methods, making treatment even more effective and accessible. Today, insulin remains a vital, life-sustaining treatment for millions of people with diabetes worldwide. It's a daily necessity for many, not just a medical breakthrough, but a life preserver. Insulin's discovery marked a turning point in medicine, reminding us that scientific advances can truly transform the world. These 8 discoveries didn't just change science. They reshaped our everyday lives and redefined what we thought was possible. If you enjoyed this journey through the 20th century's most remarkable breakthroughs, make sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay up to date with our latest videos. Until next time, keep exploring the wonders of science with us. Have you ever wondered what it took to get humans on the moon, send robots to Mars, or launch a probe that's now venturing beyond our solar system? Space missions have pushed the boundaries of what humanity can achieve, turning science fiction into reality. Each mission has paved the way for incredible discoveries and deepened our understanding of the universe. From daring manned voyages to trailblazing robotic explorers, each one is an awe-inspiring chapter in human history. Join us as we journey through 7 of the most legendary space missions, exploring the technology, dedication, and groundbreaking discoveries that made each one unforgettable and set a new course for humanity's future among the stars. Apollo 11, the moon landing. Apollo 11 isn't just a chapter in history, it's a legend. In 1969, NASA made headlines worldwide by doing what many thought was impossible, putting humans on the moon. The mission was risky, ambitious, and an incredible feat of engineering. But Neil Armstrong's one small step for man was also a huge leap in humanity's exploration of space. The Apollo program was born out of the Cold War, during the space race between the United States and the Soviet Union, pushing boundaries to demonstrate technological supremacy. But beyond politics, Apollo 11 was about curiosity, adventure, and a quest to understand our place in the cosmos. The journey to the moon was no easy feat. Launched on July 16, 1969 from Kennedy Space Center, Apollo 11 carried astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. The spacecraft traveled 240,000 miles from Earth to the moon, and on July 20th, the Eagle lunar module touched down on the lunar surface. Armstrong and Aldrin descended from the module, marking the first steps humans had ever taken on another world. With each step, they collected samples, set up scientific instruments, and planted the American flag, a powerful symbol of human ambition and resilience. Apollo 11's success was groundbreaking in every way. The mission proved that humans could survive in the harsh environment of space and return safely, opening the door to future lunar missions. Armstrong's and Aldrin's samples returned to Earth contained invaluable information about the moon's geology and its formation, teaching scientists that the moon and Earth share similar origins. These samples have continued to provide insights even decades later, revealing information about the solar system's history and our planet's own early development. The broadcast of the moon landing captivated millions around the world. Families gathered around their TVs, holding their breath as the first blurry images were transmitted back to Earth. It was a rare, unifying moment that connected humanity, even as we were divided by borders and ideologies. For a brief moment, everyone shared the wonder of exploration and the thrill of achieving something that once seemed unimaginable. Apollo 11 wasn't just a triumph for NASA, it was a triumph for humanity. It demonstrated the power of human ingenuity and courage, inspiring generations to look up at the night sky with renewed wonder. Apollo 11 laid the groundwork for future space missions and forever changed our perspective on what we could achieve, proving that the sky is not the limit, it's just the beginning. Voyager 1, humanity's message to the stars. Voyager 1's mission was to explore the outer planets, but it became so much more. Launched in 1977, Voyager 1 was equipped with a golden record containing sounds and images representing life on Earth, designed to communicate with any extraterrestrial intelligence that might find it. Initially, Voyager 1's main objective was to study Jupiter and Saturn, capturing images and collecting data that forever changed our understanding of these gas giants. But as it completed its mission in the outer solar system, Voyager 1 didn't stop, it just kept going, eventually becoming the first human-made object to enter interstellar space. The images Voyager 1 sent back were nothing short of incredible. The spacecraft captured detailed photos of Jupiter's Great Red Spot and the mysterious rings of Saturn. It discovered volcanoes erupting on Jupiter's moon Io and icy plumes on Saturn's moon Enceladus. These findings showed that the outer planets and their moons were far more dynamic than we'd ever imagined, sparking new questions about planetary formation and the potential for life in extreme environments. Voyager 1's data still serves as a reference for scientists studying our solar system. Voyager 1's journey continued far beyond expectations. In 1990, it captured the iconic pale blue dot image, a tiny dot suspended in a sunbeam representing Earth. Carl Sagan famously reflected on this image, reminding humanity of our place in the cosmos. The photograph brought a new perspective, humbling and inspiring all at once as we saw our planet from billions of miles away, a reminder of both our insignificance and our interconnectedness. The golden record aboard Voyager 1 is our message in a bottle to the cosmos. It includes music, greetings in 55 languages, and sounds from nature, intended to represent the diversity of life on Earth. Although the likelihood of an extraterrestrial finding it is slim, the record is a symbolic gesture, embodying our hope and curiosity. It's a time capsule of who we are, meant to last over 1 billion years as Voyager travels the galaxy. Voyager 1's journey is still ongoing, over 14 billion miles from Earth. Even as it travels further, this mission has forever changed how we view the cosmos and our role in it. Voyager 1 isn't just a spacecraft, it's a beacon of human spirit, curiosity, and the drive to explore the unknown. Hubble Space Telescope, unveiling the universe's wonders. Launched in 1990, the Hubble Space Telescope was humanity's first major observatory in space. Unlike Earth-based telescopes, Hubble had the advantage of being outside our atmosphere, which allowed it to capture incredibly detailed images of distant stars, galaxies, and nebulae. Hubble wasn't just an ordinary telescope, it was a window into the universe, giving us some of the most iconic images of space ever seen, from vibrant nebulae to deep-field images revealing thousands of galaxies. Hubble revolutionized astronomy and inspired millions around the globe. The early days of Hubble were challenging, though. Soon after its launch, a flaw in its mirror was discovered, causing its images to be blurry. NASA had to plan a daring repair mission, which astronauts successfully carried out in 1993. With the repair complete, Hubble began to show its true capabilities, delivering sharp, breathtaking images that opened up new avenues of research. The repair mission itself became legendary, proving that humans could maintain complex instruments in space. Hubble's contributions to science are immeasurable. It helped confirm the existence of black holes, measure the rate of the universe's expansion, and determine the age of the universe. Hubble's observations led to the discovery of dark energy, a mysterious force driving the universe to expand faster and faster. The telescope has observed everything from the birth and death of stars to collisions between galaxies, reshaping our understanding of cosmic evolution. The telescope has given us glimpses of the early universe, revealing galaxies as they appeared billions of years ago. Hubble's deep field and ultra-deep field images are among its most famous, showing countless galaxies in what seemed like empty patches of sky. These images are not just scientific data, they're visual proof of the vastness of the cosmos, making us appreciate the richness and scale of the universe beyond what we can see. Hubble has remained in operation for over 3 decades, far surpassing its expected lifespan. Its legacy goes beyond just the scientific discoveries. It's inspired humanity to look up with wonder and curiosity. Hubble's journey will eventually end, but its impact on science, art, and our understanding of the universe will last for generations. Mars rovers, red planet pioneers. Mars has always fascinated humans, and NASA's Mars rovers have been at the forefront of exploring this mysterious world. Beginning with Pathfinder's Sojourner in 1997 and continuing with Spirit, Opportunity, Curiosity, and Perseverance, these rovers have transformed our understanding of Mars. Equipped with cameras, scientific instruments, and tools to analyze rocks and soil, each rover has expanded our knowledge, piece by piece, of what Mars is really like. They've explored ancient riverbeds, climbed hills, and found compelling evidence of water's presence in Mars' past. Opportunity and Spirit, the twin rovers of the Mars Exploration Rover mission, were intended to last only a few months, but ended up exploring Mars for years. Opportunity, in particular, operated for nearly 15 years, traveling over 28 miles across the Martian surface. These rovers discovered evidence of past liquid water, showing that Mars was once a more hospitable place, potentially capable of supporting life. Curiosity took the mission further with its landing in 2012. This rover brought advanced tools to examine the geology and atmosphere of Mars in greater detail. Curiosity's findings indicated that Mars had conditions suitable for microbial life billions of years ago. The rover's data also provided insights into Mars's climate and radiation environment, crucial for future human missions to the planet. Perseverance, the latest rover, has taken the exploration to a new level. Equipped with a suite of sophisticated instruments, Perseverance is searching for signs of ancient life and collecting samples that might one day be returned to Earth. The rover even carried a small helicopter, Ingenuity, marking the first powered flight on another planet. Perseverance's mission aims to uncover the secrets of Mars's ancient environment and lay the groundwork for future human exploration. The Mars rovers symbolize our determination to explore other worlds and seek answers to the mysteries of life beyond Earth. Each rover has extended our reach across space and time, helping us piece together Mars's history and its potential as a future home for humanity. International Space Station, humanity's home in space. The International Space Station is a testament to global collaboration in space. Since its first module launched in 1998, the ISS has brought together astronauts and scientists from around the world, creating a microgravity laboratory 250 miles above Earth. This floating lab is unique because it's not just a machine, it's a place where people live, work, and conduct groundbreaking science. The ISS is a truly international effort, with the United States, Russia, Japan, Canada, and the European Space Agency all contributing. The ISS is more than a space station, it's a hub of research across fields like biology, physics, and medicine. Astronauts on board conduct experiments that can't be done on Earth, such as studying how plants grow in microgravity and how the human body reacts to extended time in space. Research on the ISS has led to advancements in medical technology and has provided insights that could help astronauts stay healthy on long-duration missions, like a future journey to Mars. Living on the ISS has also brought us closer to understanding the challenges of space travel. Astronauts spend months aboard, adapting to life in microgravity, dealing with limited resources, and relying on teamwork in confined quarters. This experience is crucial for preparing humans for deeper space missions, as it's shown us what's needed to survive and thrive away from Earth. The ISS is essentially a test bed for the future of human space exploration. The ISS has also become a bridge between countries, fostering peaceful cooperation and shared goals in space. Despite political tensions on Earth, space agencies have continued to work together on the ISS, showing the power of unity in exploring the unknown. The station has been a place of cultural exchange, scientific partnership, and mutual respect, making it a model for international collaboration. The ISS has pushed the boundaries of what's possible in space exploration and human endurance. As we look toward building bases on the Moon and reaching Mars, the lessons learned on the ISS will continue to guide us. The ISS is a legacy of discovery and cooperation, embodying the spirit of exploration and humanity's drive to go beyond. New Horizons, the Pluto and Beyond mission. New Horizons gave us our first close look at Pluto, a world on the edge of our solar system. Launched in 2006, the spacecraft traveled over 3 billion miles to reach Pluto, finally making its historic flyby in 2015. As New Horizons passed Pluto, it revealed a complex world with icy plains, mountains, and a surprisingly young surface, challenging previous assumptions. The images and data it sent back were a treasure trove, showing Pluto as a fascinating and dynamic place. The journey to Pluto took nearly a decade, but New Horizons was worth the wait. The mission showed that even the distant outskirts of our solar system hold unexpected wonders. Scientists were amazed to find signs of geological activity on Pluto's surface, hinting that the dwarf planet might have a subsurface ocean. These discoveries suggested that Pluto is far more than just a frozen rock in space. It's a world with a history, and perhaps even the conditions for some form of life. New Horizons didn't stop at Pluto. After its flyby, it continued on to explore other objects in the Kuiper Belt, a region filled with icy bodies and remnants from the solar system's formation. In 2019, New Horizons flew by an object named Arrokoth, revealing insights into the building blocks of planets. This marked the most distant object ever visited by a spacecraft, pushing the boundaries of human exploration. The data from New Horizons has transformed our understanding of the outer solar system. The Kuiper Belt, once a mysterious and largely unexplored region, is now recognized as a vital part of our cosmic neighborhood. New Horizons has given scientists clues about how planets form and evolve, offering a glimpse into the early days of the solar system. New Horizons is a testament to human curiosity and perseverance. The mission continues to send data back to Earth as it journeys further into space, reminding us that there's always more to explore. as the spacecraft ventures into interstellar space. It carries with it the hopes and dreams of those who dare to reach beyond the stars. Pioneer 10, the first to Jupiter and beyond. Launched in 1972, Pioneer 10 was the first spacecraft to travel through the asteroid belt and reach Jupiter, breaking new ground for space exploration. The mission was a true pioneer, hence the name, as it set off into unknown territory, paving the way for future deep space missions. Its close encounter with Jupiter provided the first detailed images of the gas giant and revealed its intense radiation environment. Pioneer 10's data gave scientists their first up-close look at Jupiter's atmosphere and magnetosphere, providing essential information for future missions. Pioneer 10 was the first spacecraft to venture into interstellar space, heading towards the stars after completing its mission at Jupiter. It carried a plaque with a message for potential extraterrestrial life, featuring symbols representing Earth's location and images of a man and woman. Although it wasn't designed to be found, the plaque symbolized humanity's desire to reach out to the cosmos. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.